So good morning, everyone. So today we're going to learn about tree search algorithms. So first of all, I'd like to ask you, do you guys remember what a tree is? Of course I remember because I only have 4 minutes. So a tree is a data structure that is very useful for many things, such as, for example, does someone have an idea of how can you use it? Please, Lorenzo.
Someone guesses the number, you're trying to figure out what it is.
Perfect. So, searching is a use for trees, sorting is a use for trees, decision making is a use for trees, path planning is a use for trees, and you're going to see that during all of these examples you're going to see during our lab later today. So right now I'm going to teach you 2 algorithms today, which are pretty much the base of tree search algorithms. But first of all, I want to get some motivation. So let's say that this tree here represents a cave, and you're right here, and you have monsters on each leaf, except for this one and this one, which are the meat opposites. Okay. Okay. And your goal is to start here. So, for example, Angela, how would you explore the cave in order to find the meat leaves?
So, do I know whether the meat is there already? Or no, I don't know, right?
No, you don't know. So, because I only have 4 minutes, so Angela answered. Oh, you can first take the left, and then see. Oh, this is not meat, and then you can take the left again, and then you can like take a right, and then once you say, oh, that's a dead end, so you come back and you test this one. Oh, it's a dead end. Then you come back and you test this one. That's a valid tree search algorithm, and it's actually called depth first, for obvious reasons, search. But let's say, for example, that you want to find the shortest path that takes you to meat. So this is definitely not the strategy, because you're going to always end up, hitting the very bottom of the tree. So what you could do alternatively is you start from here and you say, well, is it right next to me? So you first test here. No, it's not. So, and then you come here. Oh, it's also not here. And then you go back here and say, well, if it's not here, it has to be one of the neighbors of the rest of the tree. So you come here. No, it's not here. And then you come here. It's also not here. Then you go back to the other node, and then you finally find me. And you say, yay, I'm safe. This other algorithm, which definitely takes more bookkeeping than the first one, is called breadth-first search. So, can any one of you guys tell me what would be the advantages of using one instead of the other? For example, what would be the advantage of using breadth-first search instead of using depth-first search? Please, Alan.
Distance is a factor important to you. Distance away from your starting node.
Yes, because the more I walk, the more water I lose. So I want to get there as quickly as possible.
A lot of times it might not be possible to do depth first search because it's can keep going infinite depth.
Yeah, this is actually a very good problem, and you're going to exercise this during the lab. But so depth first search is not always possible. But the thing is, depth first search requires very little memory, and that breadth first search requires a lot of memory, but it also always gives you the optimal solution to your problem. And if you don't understand that, you're going to fail today.
Maybe not the same.
Okay, so I only have 4 minutes.